Hello everyone, welcome back to my channel. So in this video we are going to learn about intrinsic impedance. Intrinsic impedance or wave impedance. Okay, so intrinsic impedance or wave impedance. Okay, if you are first time to my channel, please consider subscribing and hit the bell icon to get video notifications from my channel. Okay, right. So what is basically intrinsic impedance? So the ratio of magnitude of electric strength, okay, or electric we'll call it as electric field strength. So electric field strength to magnetic field strength. Magnetic field strength is called wave impedance. Okay, is called as wave impedance, right? So the ratio of magnitude of electric field strength to magnetic field strength is called wave impedance. So it is represented by eta, right? So eta is equal to modulus of E bar by H bar. Okay, so magnitude, if you talk about magnitude, so it will be magnitude of eta is equal to E bar by H bar. Okay, right. So we have different forms of eta, that is different formulas for eta for different direction of propagation of wave. Okay, so we'll see all the 6 cases. If the wave is traveling along plus x direction, if the wave is propagating along plus x direction, what is the formula for eta? If the wave is propagating along minus x direction, okay, so what is the formula for eta? Plus y direction. Similarly, minus y direction. Similarly, plus z direction and minus z direction. Okay, so normally what we take is positive z direction. This is the most widely used case. Okay, so positive z direction if you take, so if you take E along x-axis, that is Ex, and H along y-axis, that is H, if you take it as Hy, okay, so Ex by Hy is equal to eta. Okay, Ex by Hy is equal to eta, or this can also be written as minus Ey by Hx. If you want to write in reverse direction, so it will be minus Ey by Hx. Okay, so Ex by Hy, or so if a wave is traveling along z direction, if you take E along x-axis, that is Ex, and H along y-axis, so we'll take like this only generally. So Ex by Hy is equal to eta, which is equal to minus Ey by Hx. Okay, suppose if it is traveling along minus z direction, so you have to remember the formula only for plus z direction. If you are asked to find minus z direction, just write everything same. Ex by Hy as it is equal to minus Ey by Hx as it is. So when wave is traveling along minus z direction, you have to write minus eta, that's all. Okay, so these are the formulas for eta in wave is traveling along plus z direction. These are the formulas for eta when wave is traveling along minus z direction. Okay, similarly if you take for plus x direction, so when wave is traveling along plus x direction, generally we'll take y along e, right, h along z, ey by hz. So plus z h plus x direction, so ey by hz, ey by hz is equal to eta is equal to minus ez by hy, minus ez by hy. Okay, so this is the formula for eta when wave is traveling along plus x direction. Similarly, if you want in minus x direction, so what will you do? So ey by hz as it is equal to minus ez by hy as it is, so this is equal to minus eta, minus eta. So I am telling you to remember very simply, right? So these are the formulas which you have to remember, because in the problems they may give you any direction of propagation. Okay, so in those cases you have to remember these formulas. Suppose if the wave is propagating along plus y direction, so plus y direction when it is propagating, so ez will take and hx. Okay, ez will take and hx, right? So ez by hx, ez by hx is equal to eta is equal to minus ex by hz, minus ex by hz. So these are the this is the formula for intrinsic impedance when wave is traveling along plus y direction. Similarly, if you want along minus y direction, so ez by hx, ez by hx is equal to minus ex by hz is equal to minus eta. That's all. Okay, so magnitude, if they asked for magnitude, this is the formula directly. Magnitude of intrinsic impedance is equal to the magnitude of electric field strength to magnetic field strength. But in the problems sometimes they may give you wave is propagating along plus x direction and find the intrinsic impedance. So there you have to find ey component, hz component, and if you divide those two you'll get eta value. Okay, so very simple, you can remember all these formulas. Okay, so let me take one more slide. I'll explain you some more concepts related to intrinsic impedance, right? So the next important point is intrinsic impedance. Intrinsic impedance in terms of medium parameters. Okay, so intrinsic impedance in terms of medium parameters is given by, that is formula is given by eta is equal to root of j omega mu by sigma plus j omega epsilon. Since it is impedance, what is its units? Ohms. Okay, so this is the formula for intrinsic impedance in terms of medium parameters. Okay, so since there is an angle here, so eta is equal to modulus of eta into t to the power of theta n. Okay, since there is j here, so always eta is a complex term, so when it is a complex term we can write in polar form, so this is called as polar form. Okay, so theta n is the angle of intrinsic impedance. So angle of intrinsic impedance, that is, it is the angle, okay, so it is the angle by which, so generally we'll take positive z direction as the reference, right? So when you talk about any concept regarding wave propagation, we'll talk about plus z direction. So it is the angle by which ex leads hy or ey leads hx. Okay, so there is some phase shift angle between electric field strength and magnetic field strength components. Okay, so when wave is propagating, phase is not same between them. That is why we are getting the intrinsic impedance as a complex term. Okay, so there is some phase difference present between the electric field component and magnetic field component. That phase difference is represented by theta n. Okay, so when you are calculating in all problems, I'm talking about problems, this is very important point, right? So when you are solving for problem during this calculation, okay, during calculation of theta n, so always assume that E leads H. Okay, so it is not compulsory, but you should have some reference to calculate theta n. So always assume that E leads H, right? So then you can calculate theta n. That means, what does it mean? So E bar is equal to E naught into e power minus alpha z cos of, right, omega t minus beta z ax cap. Similarly, H bar is H naught into e power minus alpha z cos of omega t minus beta z minus theta n ay cap. Okay, so volt per meter, ampere per meter. Okay, so this is how E bar leads H by an angle of theta n. Okay, so this is the physical representation. Okay, so if you can make the given equations of this form, then you can easily find theta n. Okay, so I'll solve one or two problems based on this, don't worry. Okay, so this is the physical significance, this is the formula for intrinsic impedance in case of medium parameters, and this is about theta n. Okay, so one more important point I have forgot. So relationship between theta and theta n. Relationship between theta and theta n. This is one more concept which you have to remember. So theta is the angle of loss tangent. Theta is angle of loss tangent, and theta n is angle of intrinsic impedance. Angle of intrinsic impedance. So the relation is given by theta is equal to 2 theta n. Theta is equal to 2 theta n. Okay, so just remember this formula. Okay, so we'll solve the wave equation. When wave is propagating in different mediums, we are now going to calculate all the medium parameters, right? So all the parameters which we have discussed, like alpha, beta, gamma, intrinsic impedance, phase velocity, lambda. So all these parameters we are going to calculate for each and every medium. So in order to solve that, we need the concept of this also. Okay, relationship between theta and theta n. So from the loss tangent concept I have explained in my previous video. So loss tangent is tan theta. Okay, so tan theta is equal to tan 2 theta n is equal to sigma by omega epsilon. Okay, so tan theta is equal to tan 2 theta n is equal to sigma by omega epsilon. Okay, so these are the concepts which you have to remember regarding intrinsic impedance. Okay.